Hello, my dear students. This is the third video of the 5 video lectures on electrical circuit. And here we are going to talk about Ohm's law. Ohm's law is the equation that will show us the relationship between the three most important elements, I guess, in a circuit, which are your current, your resistance, and your voltage. Last time we used the traffic analogy or the toll booth analysis in order to figure out the role of resistors in two different configuration in series and in parallel. So what we saw from the last two videos is that when resistors are placed in series, they add up. They add up to a total resistance. So the more toll booths in series, the slower the traffic. If we translate that, the lesser current if there are more resistors in series. But then again, if when we place them in parallel like this, more cars are able to pass through the toll booths because there are multiple pathways for them to flow rather than a single one. So placing the resistors or the toll booth in parallel have a surprising effect of improving the traffic or increasing the total current in the circuit. Another useful analogy that we can use is the water circuit analogy. So in that particular analogy, our current would be, well, what is flowing in a water circuit or along the pipes. Of course, the water would serve as the water flow would serve as the current in our analogy. Here, I guess this is not a closed system. This is not a circuit, but you get my point. Here we have a water tank here and the pipe system right here. You can see the water here in blue. But then again, here towards the end of the pipe, we have two water bulbs that are reducing the area of passage of the water. So they are placed in series like this next to each other, and we can see that passing through them, because they are present here towards the end, very few amount of water is able to, I guess, get out of the pipe. And then, but if we place it in parallel like this, because there are two pathways now, although there are two water bulbs like this, we end up with more water that is able to get out of the pipes, right? So this is the water circuit analogy, is also another way of understanding the effect of resistors when placed in series like this or in parallel to the current or to the water flow, to the volume of water that is able to pass through the pipe. In water analogy, resistance is anything that restrict water flow. In our previous example, those are the water valve. But there must also be pressure, right? There must also be water pressure that would push the water from one point to another, right? So that would be the voltage in that analogy. Voltage is the pressure that pushes the water along the pipes. If you have more pressure, you have more volume of water coming out of your pipe. That means if you have higher voltage, higher pressure, more water flow, higher voltage means higher current, or it increases your current. That is the relationship between voltage and current. So you can say that they are directly proportional to each other. But then if you have more resistance, especially if they are connected in series, the result is it decreases the amount of water that is able to flow. There's a decrease in current if you have higher resistance. So you can say that the relationship between current and resistance is inversely related, or there's an inverse relationship between the two. If we express that in an equation, what we get is this one. This is the Ohm's law. Current is equal to voltage over resistance. So the more voltage you have, the higher current you get. Just like if you use 12 volts battery, there's more, your light bulb will be brighter as compared with using, let's say, 9 volts battery. Your resistance is in the denominator, so the larger this gets, the lesser your current is. These are your units. Take note of this. Current is amperes. You can abbreviate that or symbolize that as capital A. Voltage is, of course, volts. That's capital B. And as we discussed, resistance is ohms or Greek capital letter omega. In symbol form, the formula can be expressed as I is equal to V over R. I for current, V for voltage, and R for resistance. You can rearrange this to come up with a different expression of the same formula. V is equal to IR. Voltage is equal to current multiplied with resistance. Okay, let's use them in sample problems here. So here we have a light bulb and it has a resistance of 300 ohms. It's connected to your power supply, rated 120 volts, like this. And we want to find out how much current is flowing through the filament of the light bulb. So I guess we can use I is equal to V over R, right? Since we're looking for current, 120 divided 300, your current is 0.4 amperes. Okay, now in this one, you have a battery. Your voltage is 1.5 volts. And do you have I guess you have a simple circuit. The battery is your power source, but here we have three resistors in this simple circuit. R1 is 100 ohms, R2 is 200 ohms, and R3 is 300 ohms. You are asked to get the total current, right? Total current. So that gives you an idea that maybe I have to compute for the total resistance first, right? So since your resistors are in series, this is very important. You just need to add up your resistances, right? R1, R2, and R3. The sum is 600 ohms. Now we can compute for the total current. That's just the total voltage provided by the battery. It's 1.5 volts divided by the total resistance. Since there are three, you add them up and they are in series, so you add them up. 1.5 divided by 600, your current is 0.0025 amperes. Okay, so that's your Ohm's law. Just remember the equation, I is equal to V over R, or you can rearrange the variables to come up with V equals IR.